Alright guys, I promised I'd do a little comparison between Rob's 340 block and that's actually Big Mike's old pickup truck block, which is an 010 block. It's a good heavy duty 4-bolt block. And the first thing I was surprised was how thin the cylinder walls are on a 30 over 340 block, and then I compared it to the Chevy block and they're almost the same. So obviously that's not a problem because I know how hard I beat 30 over 350 blocks. Now Rob wants some big power out of this. This is going to get the W2s done up with the tunnel ram and big solid lifter cam, big solid lifter roller, and it's going to get stroked. It should make good power. But let's talk about some basic engineering and some parts that I like and some parts that I don't like. And it's like that with any design, really. You know, they all have their good points and bad points. First bad point I don't like: 4 bolts around each cylinder. Why don't I like that? Well, the LS went to 4 bolts per cylinder. Yeah, but they also secure in a different place. They secure much deeper into the block and cause less distortion at the deck face. Okay? Chevys, 5 bolts per cylinder. They spread it out a little bit more, a little bit better design as far as I'm concerned. The decks themselves seem to be about the same thickness. It's a little tough to actually measure because all the holes are so small I can't get my fat little fingers in there. And I guess I could use the Sonic on it. Let's do the Sonic and see what it says. Okay, can't get... Alright, let's do... Okay, can't get a good measurement on the Sonic, but it seems to be about a 3/8 of an inch thick deck. And the Chevy's definitely thicker. Okay, so points to the Chevy for the thicker deck. Important. Okay, lifter design. Chrysler's got 2 different lifter designs. I don't even know what they are. I should, but I don't. Sorry. Rough week, guys. Really rough week. And in any case, I don't like that the lifters are on a different plane than the cylinders themselves. I like everything to be straighter because now you have a lifter on an angle and the push rod interface, right? The push rod comes in more at an angle like this. Not, I'm exaggerating. But what that's going to do is it's going to put a lot of thrust on this part of the bores. Now I doubt many guys have lifter bore wear problems, even running a big size spring, because Chrysler did a major improvement over Chevy, meaning they put a giant lifter in there. I think it's a .902 versus Chevy's .842. That makes a big difference. The diameter of that lifter makes a big difference in how much side load it can take. But it adds weight. So that's the problem with the bigger lifter, right? It adds weight. And since we're an overhead valve design, weight is a huge consideration, right? You got the lifter, you got the push rod, you got the rocker arm, you got the retainer, lock, valve, and spring as far as weight. All that has to be taken into consideration. As far as the Valley design, these big open holes, Rob would like to close them all up. Me, I was always under the... all my stuff was always street stuff, so I didn't mind oil coming through and oiling my lifters and my cam and a little extra oil on the crank. I never really worried about it because I figured extra oil flopping around in there is probably good. Race stuff, you want to keep as much oil off the crank, keep windage losses down low. Okay, Chevy Valley design, all solid with an oil gallery going through it. As far as I'm concerned, it's much stronger keeping the 2 halves of the block together. Okay? Yeah, I'd like to choke the engineer that thought this freaking huge pointy boss on the side of the block is a good idea, because I just had a battle between my head and that boss. My head lost. Okay, front of the block. Couldn't care less, to be honest, guys. Not even a little bit. Okay, back of the Chevy block. You got your camcorder plug. You've got your water jacket plugs. You've got a couple plugs for your oil galleries that feed your lifters into the front of the engine. Chrysler, we got a different shape bell housing, but it all looks about the same, right? About the same stuff all the way around. Two-piece seal. All basically the same idea. Okay, take a look at the cap design, right? 4 bolts. Some of these are even nodular. I don't remember if this is a nodular iron cap or not. I could always check the numbers, but in any case, this was a good block. I don't remember I think it was a 2.8 something number for nodular iron caps. What's the difference between nodular iron and regular iron? Well, they changed the metallurgy a little bit, so it's a little stronger as far as resisting cracks, right? Like they do to the cranks. Nodular iron crank is pretty darn tough, especially if it's machined right. All right, let's take a look at what the Dodge looks like. Okay, that's how wide the Chevy cap is. Let's measure it up to the Dodge cap. Okay, center cap is considerably wider, but Dodge uses the center cap for the thrust. Chevy uses the rear main for thrust. So let's take a look at how wide the other mains are. Okay, pretty darn close on the other caps. Now, this is only a 2-bolt block. They did make, I think they made 4-bolt 340 blocks, but they weren't regular production. I could be wrong with that. I'm not an expert when it comes to this stuff. You can see somebody had already started doing some work to this block. It's got ARP studs in it, which I like. Problem with the ARP stud is don't fit that. Can't get the oil pump on with that. We're going to do some work on the oil transfer slots, and we're going to deburr this whole thing and go through every inch of it. And obviously it's going to get new bearings and so forth. Side of the block. What's to talk about? Yeah, they put the oil filter in a slightly different location. This, I don't know how they do their oil bypass, whether there's an adapter that goes on that or not. Chevy has an adapter that goes into that. Okay, we got 3 freeze-out plugs on the side. Overall, the amount of meat we have on the mains is really important. Let's take a look, see if we can figure out how much meat we got on the mains. Now, this necks down quite a bit. Let's take a look at the Chevy, how they did it. Okay, the Chevy has, the main stays that thickness, but then has a big notch for the bore. So this area right here is relatively thin. That's only maybe 3/4 of an inch. As far as width, let's measure them. They should be about the same. Okay, that's how wide the main bulkheads are on the Chevy. Okay, so this is how this is the Chevy measurement on the Chrysler block, and let's see, on this side you can see it necks down quite a bit. So I'm going to say okay, the part I don't like about the Chevy design is it's kind of like a sharp angle where they took that notch out to clear the cylinder. I like the way this is radiused here, and I'd like that this is a smoother angle than the way that Chevy did it. But Chevy's got more material there. Plus, it has more fasteners. Now these are larger fasteners, so the load holding the cap due to the torqued bolts is probably pretty close. Okay, in any case, This is this lower end, I'm sure, can handle a good amount of power. Now, small block Fords are notorious for being really, really thin in this main web area, and that's pretty darn thin as well. You can see all the oil galleries coming to that that front crank journal. I think Dodge does a little bit different oiling system than Chevy. I think Chevy's got the Dodge system beat. Chevy oiling system is pretty darn tough. And I mean, I always used to use high volume pumps, and then as I learned more and more, that not even necessary for almost all applications, really. That's how tough the Chevy oiling system is. Okay, so the Chevy necks down a lot under the front main too. You can see it's only got one oil gallery hole going down to the crank. Yeah, I'm going to say there, I think I like the Dodge a little bit better than the way the Chevy did the front main. That's a little weaker than I'd like to see. It does seem to be, though, whenever these crack, they seem to be towards the center of the block, but this is an 010 block. It's guys have made a lot of power with these blocks. This one was obviously just put together with GM bolts. This was a experimental engine I did for Big Mike up north in the People's Truck. Had 11-to-1 pistons, 350 crank, 307 cylinder heads with the tight chamber, steel shim head gaskets. The compression was ridiculous, and I used the shortest Magnum flat tappet cam I could with 165 rockers. So it was only like 206 duration, 489 lift, something like that. And I made a custom high torque 2-plane intake manifold for it, custom spacer, annular discharge Holley, headers, dual exhaust with a crossover pipe. Did it for towing. Unfortunately, the compression was high enough that it was an absolute bear to time. But he got accused of having a big block under the hood many a time with that thing. It was a good running truck too. I know I blew the Turbo 400 and one time I borrowed it. Oh, good times, good times. Yeah, Turbo 400s are pretty tough. How do you blow a Turbo 400, Charlie? I've blown about 3 of them. Oh well. Okay, the Chrysler block has got a taller deck height. Well, that's great for stroker applications. It's also got more room in the lower end of the block. It's also heavier. So if you want to build a big inch engine, I would say the Chrysler's probably advantageous over the small block Chevy, especially the 350 block. The 400 block has got a little bit more metal taken out of the cylinders and stuff on the bottom, so you can fit a little bit bigger crank, but still they're tight. Even a 383 on a Chevy needs decent amount of clearancing. All right, guys. I promised I'd do a quickie overlook on the 340 versus 350 block. And like I said, there's things about both of them I like and dislike. But then again, I've been building Chevy since I was a kid, so this is the first 340 block I've seen in real life. So, gives you an idea of how many of them are out there. All right, guys, thanks for hanging out. Have a good night.